Hey everybody, in this video we are looking at the 12th video or 12th example on a playlist of PreCalc Final Exam review content. Here we have the function g of x equals 2x squared minus 5 over x minus 1, and the directions only say to list asymptotes and wholes. I will, knowing me, probably end up graphing it because I can't always help myself. So if I was just doing asymptotes and wholes, I guess I'm going to try my best to just, reel it in and just do that. Vertical asymptote you get by setting your denominator equal to 0. You do want to make sure that you remove any removable discontinuities. X minus 1 is not a factor of the numerator very clearly, so I don't have to worry about that crossing out. I would set x minus 1 equal to 0 and solve for x, so x equals 1 is your vertical asymptote. After that, my end behavior. I am analyzing leading term over leading term. I'm looking at 2x squared over x, which is approximating, worst squiggle equals sign. It's approximating my end behavior to be 2x, which means it's linear, which means it is slant. But that again is an approximation. How do I get my exact asymptote? Division. You can use long or you can use synthetic. If you use synthetic, you can put 1 in the box right here. 2, 0, and negative 5 go across right there. Bring down the 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Negative 5 plus 2 is negative 3. Your negative 3 is your remainder. This here, you divided a quadratic by a linear. That makes this linear. Some of you on a recent assessment were making that the same power as the thing you started with. Not good, I have to say. If you're in pre-calc, that is not good. That is algebra, okay? That's old. You are responsible for everything you've ever learned when you are now in pre-calculus. You are responsible for it. The end, okay? So this is 2x plus 2. Technically, you're minus 3 over x minus 1, but because it's end behavior, this end behavior is 0. It falls off essentially. So we are indeed allowed to ignore that, and sorry, I'm not looking what I'm doing. That right there, y equals, is my actual slant asymptote, 2x plus 2. So I have my end behavior, that's my one asymptote. I have my vertical asymptote, which was x equals 1. And it said to list any wholes, but there are no wholes. If you are curious about what does this graph look like, I will very, very quickly do a little sketch-a-rooney. So 2x plus 2 is the slant. 1, 2, up 2 over 1. Not the straightest line I've ever drawn, but we're doing our best. X equals 1. Oh man, no, I should draw this lower. I'm going to regret this, so. Okay. 2x squared minus 5 plus 2. Okay. Okay. That's a little bit more room. That's a little better. 1, 2, buckle my shoe. 3, 4, 5, 6, 7. That's about 8. And okay. Now I will draw. Sorry for that. 2x plus 2. There's the y-intercept. Up 2 over 1. Up 2 over 1-ish. Down 2, left 1, 2, 1. Boopity, boop, boop. There's your slant, okay? Your vertical. Right there. Now, for your x-intercepts, okay? We can get the x-intercepts by factoring the numerator and setting it equal to 0. It is a difference of squares, so you can think of it as x root 2 plus root 5 times x root 2 minus root 5. But to be honest, looking at that is pretty messy. You will get the exact, you will get the exact same answers. Sorry. If you just do wrong marker. 2x squared minus 5, just setting it equal to 0 because we could solve by taking square roots in this case. So 2x squared is 5. Divide both sides by 2. Then take the square root plus minus. So plus minus the square root of 5 over 2, which is rationalize root 10 over 2. So that's a little more than 3 divided by 2. So 1.6. Okay, so just do that on the side yourself. I have a lot of faith in you. Plus minus radical 10 over 2. It's a little bit bigger than 1.5. It's less than 2 though. So those are your x-intercepts. My y-intercept I can get by filling in 0 for x. Negative 5 over negative 1 is positive 5. And that's right there. So now if I go ahead and draw this, okay, even though it doesn't say I have to, I'm going to have to pass through my y-intercept, my x-intercept, and I'm going to have to approach my asymptotes. That's what they are for. They're for us to approach. And then that right there, I'm approaching those. So that right there, beautiful. We love that. We love that so much, okay? So here's my graph. And done, okay? Very lovely. Read through it again. But really, what did this want for an answer? Asymptotes, we have our vertical asymptote, x equals 1. Our end behavior is a slant asymptote, slanty slant. The real one is there. Now, what is 2x good for when you're doing limits at infinity? Good enough, because we don't need to be specific. We're not near 0. We're at infinity and negative infinity. What do I care about that plus 2? It's nothing to me when I'm at infinity. So the 2x right here from the approximation, that's good for the limit at infinity situation or negative infinity. That's what that's good for. For graphing, okay, for graphing, we want to be nice and specific because we're probably focused on stuff going on around the origin, okay? That's the end of this video. Sorry, I went off on a mathy tangent here, but I think it's beneficial. If that is clear to you, you got it right, you're happy and you love it, thumbs up. If not, thumbs down. Questions, comments, concerns, requests, and feedback can all go in the description, or not in the description, in the comment section. Check the description. I will put the video on how to graph rational functions in the description box, as well as on a thumbnail on the screen right now, as well as the link to the playlist of the other pre-calc final exam review videos. That's it for now. Adios.